Thank you. So, first thing, thank you for being there this morning, because it's not a really late talk. But so thank you for those being in the room here. We'll talk about Metabrik platform, which basically is used to quickly develop the tools you want. And my goal is to make you think it's really cool and you will want to use it. So who am I? I'm known under the handle Gomor. I'm an information security engineer for 15 years now, and Perl developer for the same amount of time. I said the word, it's Perl, not Python. I'm a CPAN author for various Perl modules. In 15 years, I did some modules, of course. Netpacket, maybe some people used it in the past. It's a module to easily craft network packets to inject them on the network and get responses. It's a sort of SCAPI in Perl. But it was quite complex to use, so I rewrote it to make it even simpler and more modular, and it's now the NetFrame suite. There is also the NetWrite module, which is used to send packets at various layers. If you want to inject packets at layer 2, at layer 3, or at layer 4 on the network. But that's not the subject of today, so I will skip on that. I presented also already in the past CNFP3, which is an OS operating, an operating system fingerprinting suite. Yes, it was back in 2012. But today it's about Metabrik. So what is Metabrik, apart the subject of today? It's not a Pokemon, even though there is a Pokemon card, at least in French. Funnily, I found it after decided the name of the tool. But it's a platform and much more. I merge three features in Metabrik. The first one is to have a Unix-Like Shell, and so you can use a shell replacement on your daily stuff. A true language with a read-eval print loop. Python developers are used to such a read-eval print loop, but not in Perl community, so that's why I wanted to do that also. And of course, many bricks, which helps you finally to quickly develop or prototype some new tools. Because in my experience, there is you need something quick and now, so you have to have the good tools to do it. So true language, I said it. I said the word. It's written in Perl. There are many reasons to use Perl. Well, for me, the primary is that this is the language I master, so I'm using Perl. And yes, the picture is, it should give you the will to use Perl. Why did I develop Metabrik? I'm a CLI lover. I want to be able to do everything from the command line. So I want to be able to automate all the things from the command line. And I also started to apply the do-it-once principle because I was tired of always writing some throwaway script to do something, and the next time I wanted to do the same stuff, I didn't find the script I wrote earlier. So, well, I was tired of doing again and again the same stuff, so I developed Metabrik also for that. Regarding Unix shells, I found the pipe too limited for my needs, and that's why I thought about a new mechanism to make bricks. We will see that in a few slides. And for that, I needed a powerful language. Perl is a powerful language, so it was okay. It allows you to rapidly develop a new tool directly from the command line. You write Perl code directly on the command line and you have the result. And you can finally write scripts so you don't have to type again and again the same commands in the shell. And I wanted a normalized syntax because I don't know if you are like me, but every tool has its own usage rules, its own flags, sometimes quite cryptic, and I wanted something easily readable by a human. There is another tool which came up a little bit before Metabrik, which is called Rebus. It has been presented at a French security conference in the past. And the goal was exactly the same, normalize tool usage. But for Rebus, the goal was to automate interaction between tools. And in Metabrik, I didn't want to automate the interaction between tools because I want to let the human decide on what he wants to do. And Rebus is not a shell. And again, its usage is not so easy, so we are with some cryptic arguments to pass, and you have to really understand how it works to use it. But basically, both are wrappers around existing tools. And Metabrik is not only wrapper about existing tools, there is some own development within Metabrik. And each time I write a brick, I try to use the best CPAN modules, because for those familiar with CPAN, you may have multiple modules doing the same thing, so you have to test which one is the best. And so I did it each time I write a brick, so I don't have to check again which is the best CPAN module. Time for the first demo. I will show you how to use the shell with the 3 kinds of command lines. You can, like any Unix shell, you can call any external binary program. You can call specific bricks commands. This is where you have some specific Metabrik stuff. And of course, it's a Perl interpreter, so you can directly type some Perl code. And using the bricks is as easy as knowing 5 commands: use, set, get, run, and help. Use to load the brick, set to set some property on the brick, get to have information on values for properties, and run to execute a command, and help, of course, to have some help. So, first demo. I recorded the videos because I always forgive what I want to do when I do it live. So, first thing, you launch the Metabrik shell. It loads a bunch of bricks. This is the bricks I'm using for my work. Here you see it's a Perl interpreter, so you just type some stuff, and here it does basic math. You can define some variables, a Perl array here, and it outputs. You can see the content of a variable easily by just naming it. You can do it for hashes also. You dump the content easily, so you can explore structure. Now I want to use a Perl module to do some stuff. I want to check my network interface, for instance. So I load a module, I instantiate the object. Here, it dumps the content of the object. You can call method on it. Well, that's basically a Perl interpreter. And finally, you can use, yes, that's a shell, so you can change to any directory, list what you have. As you can see here, the output of ls command is translated to a Perl array directly, because in fact, ls here is an alias, and it's an alias for the shell command brick capture method or capture command. So if I run that, it's exactly the same. Well, that's an alias. And the output of a run command is automatically saved in the $run variable at the end of the screen. And so it's a Perl array, so you can just call, if you want to gather the last file of the array, you just call it. If you want to count how many files you have, well, it's just a matter of a Perl command. Yes. So if you want to see what you can do with shell command, this is the brick to call external commands. So every external command goes through this brick under the hood. And yes, now I want to use automatically use sudo for my next commands. So I set the attribute use sudo to true. Here you can see when you call the set command, the $set variable is automatically set to the value. It can be handy sometimes. Get is the same. It's automatically set to the value of the attribute. So now I'll call ls again, and it automatically calls sudo. And the output is saved in your user session. So you don't have root privileges anymore here, and you can play with the output of the command. So that's really handy. Okay. So that was for the shell. Features, most notable ones. You have the built-ins, CD, alias. You can customize the shell with the .metabrik rc file. You have history handling. It's like a Unix shell. You have meta-exploit-like syntax, you have seen it. And completion for commands, for files, for variables, for brick names. You have completion everywhere, so you have to type the minimum of characters to use it. And because it is using the GNU lib readline, you have all the control keys, you have Control R to search for your history. What is a brick? So I said it, it's wrappers around external programs, but not only. But a brick is an object and is defined by a set of properties like tags, category, or attributes. And because it's object-oriented, a brick may inherit some property from another one. So it's easy to write a new brick which looks like an existing one. For instance, the file PSV brick is able to handle pipe-separated values, and it just inherits from the file CSV. You just change the separator. Instead of comma, it's a pipe. You can add features to existing tools, because in my experience, the tool I'm using always likes some feature, and it may not be easy sometimes to add the features. So you can, by external growth, add some features. For instance, in Scalpel, I will speak later if I have time regarding Scalpel. In the end, a brick is a reusable Perl module you can use from the command line interface or from a classical interface, I mean in any Perl program. The brick tool is something which helps use Metabrik, because a brick depends on external programs or Perl modules, and brick tool make that really easy for you to use. You just call the run brick install command on the brick you want to use, and it will install all the dependencies. For a civil search, it will even fetch the GitHub repository, copy files where it needs. Well, everything is done under the hood for you. You don't have to care about that. Then you use the brick and tip help, and it says what you can do with it. The Metabrik itself is updated really on a daily basis, and you have a brick tool update command, so you can be always up to date on it. There are some special variables. We have seen some of them, so we'll skip this slide now. The demo 2 I will show you if I have time at the end, because time is running. Metabrik is composed of two main components, the Metabrik core and the Metabrik repository. The Metabrik core is made on a base class, the Metabrik base class, and 4 bricks: core global, core shell, core log, and core context. In fact, every command you type goes through the core log module, so you can trace every action you do in Metabrik, and you can replace the core log module by your own one if you want. Core context is where everything is kept in memory. For instance, variables you have defined in your shell. Well, I don't suggest you to look at the code for core context because it's some Perl magic and your eyes may bleed. The Metabrik core has minimal system and Perl modules dependencies to make it easy to install. And Metabrik repository, where is most of the interesting bricks, of course, is a separate module to install. with nearly no dependencies at all, because dependencies are handled with Brick tool, as I've shown you just before. It's more than 200 bricks, and I regularly create new bricks. So, with so much bricks, you may say, but how do I find the brick I want to use for my work? That's why bricks are tagged, and you can use a brick search brick to search what you want to do. For instance, if I run brick search tag video, it ends up with some brick related to video, and the demo I recorded was recorded thanks to a brick, so I don't have to remember how to record my desktop again. A brick tool can also help you to create a new brick. You just call the create brick command and you have a skeleton of a new brick. So that's really handy. And the create tool to create a skeleton of a new per script. If I don't have screen anymore. Okay, at least one. Here you can see at the top, from the shell, you use a brick and you call a command. Here it just do JYP location for an IP address. If you want to do it in per program, thanks to the create tool, it will just create the skeleton here to load the core context module, and after that you have to use the module and do your stuff. So demo 3. Here I want to be able to analyze the malware, but I'm not a reverse engineer. And I just want to take a screenshot of a virtual machine before the execution of the malware and after, and perform a diff on what happened. So for that, I have to use multiple bricks. One is a system VirtualBox, so I can automate interaction with VirtualBox. And some others are remote WinExe and WMI to execute commands remotely on Windows machine or to fetch some attributes. And in the end, I want also to use volatility to perform diff on memory. So. Okay. So first thing to do, I want to start my virtual machine. So I call the list command. As you can see, everything in Metabrik is outputted as a per variable, so you can use it like a per variable. I want to start the Windows 7 machine. I gather its ID. I verify it is started. Yes, it's already started. But just to check, I will start it again. But well, okay, it says it's already started, so no problem. So I will execute a command to test it works. Here cmd.exe, so it gives me a shell to the Windows machine. Perfect, it works. In this example, I will execute calc.exe as a malware. So it's just a proof of concept here. So get win from the process is a WML stuff. So I'm searching everything if it's larger than the screen. The screen is outputted to less, so you can search for the result. It's a cool feature. So now I execute calc.exe. Okay. And I search again. And it failed. Yeah. Because I didn't call the good method. I have to execute it in background. Because I did abort the stuff by using Ctrl+C. So execute in background the calc.exe. Now I check again the process list, and okay, so I have the malware has been executed. But I want to do the same with volatility. So in VirtualBox, you can dump the content of the memory. Here, as you can see, I didn't remember how to use it, so I just use the command without an argument, and it saves me, it gives me some help on how to use the brick. So I dump the VM memory. So in VirtualBox, it's an ELF file which is outputted, and you have to extract just the memory part from the ELF file. So there is another command to just extract that information. And now we have a file volatility can read. And you call the pslist command for the brick volatility on the $run because it has been saved in the last command. And you should have, if you search for calc.exe, okay, so you have it. So you can see it's again a Perl variable which is outputted here. So, but that's great. Now I used some bricks to do some separate small jobs, but this is something I want to automate, and I can simply write a new brick which will do all of that for me. And that's really one of the goal behind Metabrik, is that the more brick you write, the more easy you will be able to write new bricks and do new stuff. So I call the new brick remote diff. In fact, we made aware yesterday that there is a tool called volatility diff, which just do the same kind of stuff, but I was not aware of it. So how to use it? You call help on the brick. So you can see you have a bunch of commands available here. You can restart a VM remotely, take a snapshot, upload a file, perform a netstat diff or a process diff before and after execution of a program. You have a set of properties to define your username and password to connect to the remote host. Everything has been set, so you will not see in the demo how you just call set on the attribute and set the value, which is not complicated. So first thing, I want the VM to be in a good state, so I restart the VM first. I ping it, I'm waiting. In fact, you will not see the VM because it is started in headless mode, because really I want to do everything on the command line. I don't want to see Windows at all. So now I go to my tools directory. Up. Okay, the VM pings, that's great. Okay, so I will first upload netcat. Here the malware is just netcat. I will upload netcat to the target. Okay, great. It's calling SMB client under the hood. Now netcat is uploaded. I take a snapshot of the VM before execution of the malware. So it's dumping the VM core, extracting the mem dump. Okay, so I save the file name for later use because you want a diff, so you will have to use that again. Now I execute the malware. This command is not simple enough. I have to simplify it. But by default, the file is uploaded to the C Windows 10 directory, so I call it here. I will just do a connection to my website. Okay, this time it's calling the execute in background command, so there is no problem. I take the snapshot after executing the malware. So again, dumping the VM core, extracting the memory dump. And in the end, we have the state before and after execution of the malware. So now I want to know what has changed regarding processes between these two rounds. So I perform process diff against before and after. So it's calling the volatility pslist command again. So what can I see? I have a few new processes. I have my netcat.exe, cmd.exe. That's okay. There is also avg, so I should have turned off my antivirus because it is bugging me on the result. But well. And netcat is probably calling conhost. I'm not very familiar with conhost.exe. So I save the output for later use. And now I want to do a netstat diff to see if there has been some network connection made from this malware. So that's exactly the same stuff. Perform netstat diff. So you have the output here. you have 3 connections. One of them is again the AVG, the second one is also AVG. So it is bugging me. But anyway, you see netcat is connected to an IP address, so yes, you have been able to see the new connection from the malware. So again, I've saved that for later use. Okay. So it was a remote WinDiff. So that's great. I wrote a new tool with existing bricks, but I'm a user, and there is some feature which is lacking. So I want to do some more stuff. For instance, I want to save the output as a CSV file. That's great. There is a brick which exists exactly for that. So you would just call run file CSV write $process_diff out.csv, and you have saved the output in a CSV file. You want to do a reverse lookup on the IP address. You also have a brick for that. You want to use the virus total API to check if this IP address is malicious or not. So you use virus total API, same with showdown if you want to get some information. You have more than 200 bricks, so chances are if you want to do something, there is a brick which at least can help you do that. Some of the best bricks in the API category, I'm a Splunk user, so I have an API to interrogate Splunk. It's not complete because Splunk API is quite huge. You have a client Elasticsearch, because I do have an Elasticsearch cluster, so I want to check the state of my shards, all of that stuff, so I wrote it here. MongoDB, Redis, REST, if you want to interrogate an API, REST client is always useful. You want to automate SSH stuff, so you have a client SSH, Twitter. Maybe you want a REST server. There is a REST server, so you can weaponize a brick by calling a few commands to make a brick accessible via REST API, and gives you the output as a JSON, because you have some string conversion stuff, and you can play with JSON or XML or whatever. You want a DNS server to perform a man in the middle and spoof the answer. There is a server DNS brick. Well, you have seen you have many bricks. In the network category too, if you want to parse the output of Nmap, you should use the network Nmap bricks. The output is already parsed. I talked about the CNFP3, which is an OS fingerprinting tool I developed. And it was quite complicated to install, but because now there is a brick, it's just run brick tool, install a network CNFP3, and you can play with it. So it makes things really simpler. Conclusion, more than 200 bricks. Every tool, in fact, becomes a per variable. In Unix, everything is a file. In Metabrik, everything is a per variable. You can automate really all those things from the command line. You can add missing features to existing tools. Because tool usage is normalized, it helps you reuse a tool. I wrote some brick maybe 1 year ago, and during 1 year I didn't use it, and I found it again, and well, I could use the thing I wanted to use with no headache directly. So this really, it helps reusability. It's shell unification also. SQLite has its shell, Redis has its shell. Many tools have their own shell, and here you have the same shell for any tools. Paul, yes, who would be interested in a workshop if I did do a workshop on Metabrik? Yeah, few people. Okay. So I don't know if I have a few minutes left. Maybe if I can do the other demo, or yeah. Okay. So I will go back to the Scalpel stuff. Yes, Scalpel so is a forensic tool to carve some files from binary data. And for me, it lacked two features. To easily generate the configuration file, because the first thing to do is to generate the configuration file to say how to extract which kind of data. And the second one is that it extracts files without checking the MIME tip or the magic tip. So you have to do it after extraction to verify the file it extracted is really what you wanted to extract. So for this, I used a challenge, a root me challenge. The idea is some bad guy kidnapped your cat, and you found some device on the crime scene, and you have to carve that together information, and in the end find your cat, your missing cat, and you will have to use a few bricks for that. So the demo. So the challenge in French is named Trouver le chat, find the cat. You have two files. So because ls is captured, you do ls and save the files for later use. You will use a file type brick to check for MIME and magic types of the file. You see a href with, so this is a gzip file. Okay, MIME type again. So okay. I have to uncompress this file, of course, because it looks like really a compressed file. So you call the uncompress command. Whatever the compression method used, that's not your problem. The brick will take care of that. It will, in fact, check for the MIME type and call the correct command to just uncompress the file. Okay, the file is uncompressed. I save it for later use. Okay. Check the MIME types again. So this time we have what looks like a file system. It's a partition, so that's a good candidate for file carving. You load the brick. Well, here you have an error message because it's already loaded. And you want to generate a configuration file to extract some kind of files. Because I know the result of the challenge, I will just generate a configuration file to extract open Office document. So the file is generated. Now I can call scalpel scan command to find the files. Okay. And here you can see you have two attributes. One is unverified files, and the other one is verified files. Verified means this is truly open Office document. So again, I know the result of the challenge, so I go directly to the good file. I get the magic tips. It's not really useful here, but well, just for the demo, it's really an open Office document, open document text. Sorry. Again, you have to know that you can uncompress such a kind of document. So you just call again the file compress and compress command on the file. And I know the result is in the GPG file, so I'm getting that. Yes, that's my cat. I know him. I've seen him. It's a JPEG file, so you want to extract the metadata. So you call get metadata on it, and you have some GPS coordinates. So I'm just here. So you have found your cat. So it was easy. Okay. Conclusion. I do have some time, or it's okay? So I can show you some source code. Oh, okay, perfect. So I will just show you the source code of a brick. I hope it's readable Perl, you will say. So the remote WinDiff inherits from the client SMB client brick. So you can upload files, download files from the remote machine. So a brick is defined with a set of properties, like attributes, to set username, password, the volatility profile here. You can define default values for attributes, of course. Windows 7 SP1 is a good choice for volatility. You have the commands. In fact, this defines the help here. You have how to use the arguments. And the required modules. Here you require 4 other bricks to write it. So upload, because you inherit from a SMB client, you just have to call the upload on the stuff. You have argument checking in each command. So you have always the same kind of error messages. So that's handy also to understand what happens. I want to execute a command, so I instantiate the remote win exit break, I set his attributes, and I can call it directly. So that's as easy as that. I want to restart the VM, it's the same stuff. You see, it's started in headless mode. You take a snapshot on the VM, so you instantiate the system virtual box again, you call the dump core. Error handling is also done in the same way for every command. And so when you use it, you just call the command and do or return, and you will have error messages, and execution will stop if there is an error. So you don't have to take care of error handling by yourself when you are using some existing bricks. So the process diff, okay, you call PS list on the first snapshot and PS list on the second one, and you perform a diff on the two per structure. It's very easy. Okay, let's start, same stuff. That's okay. That's the code is available on the track Metabrik. You have some help on how to install it. It's quite easy, and you even have a Docker image for those who don't want to bother with reading how to install the tool. You do a Docker pull Metabrik, and you have the stuff installed on your computer. Questions? I have been crystal clear. Okay. Thank you.
Thank you. Thank you, Patrice.